Hey guys, today I'm going to show you how to determine the general solutions of the trig functions. As you can see guys, we have our first equation which is given in the form of sine 2x equal to cos x minus 30 degrees. Then our second equation is given in the form of cos x plus 30 degrees which is equal to half sine x. So guys, before I proceed, just click on the subscription button so that you can be able to always get notified whenever I upload a video. As we proceed, so guys, we have two equations here. So these two equations, they might look similar, but they are completely different from each other, even in terms of determining their general solutions. Like we are going to apply different methods to determine the general solutions of these two equations. As you can see guys, on our first equation, the coefficients are equal to 1. Like for instance, the coefficient of sine is equal to 1, which is an amplitude. Even the coefficient of cos is equal to 1, which is an amplitude. But when it comes to our second equation, the coefficient of cos is equal to 1, but when it comes to sine, our coefficient is equal to half. So those are two things that makes these two equations different from each other. So guys, in order for you to determine the general solution for the first equation, you just need to apply the co-ratios. But when it comes to our second equation, we have to apply the compound angles, right? So let's start with our first equation and apply our co-ratios. So a co-ratio, we have two co-ratios. Sine theta can also be expressed in the form of what? In the form of cos 90 degrees minus theta, right? Yes, so these two values, they are equal to each other. If you can plug 1 wherever you see theta, you can replace theta with 1, then punch sine 1 degrees, then you are going to get the same answer even if you can just punch cos 90 degrees minus 1. So these two things, they are equal to each other, right? Yes, so those are called the co-ratios. Even cos theta degrees is equal to sine, then you can just say 90 degrees minus theta, this angle, right? So those are called the co-ratios. Then in order for you to apply that on this, so we're gonna apply these co-ratios on our first equation. So let's have number 1. So let me say solution. Then we have our number 1, which is sine 2x equal to cos, then x minus 30 degrees. So here we are going to apply our co-ratios. But when it comes to our second equation, on our second equation, we are going to apply the compound angles, because we have the coefficients of half. This side we have 1, so they are different. The coefficients, which are the amplitude, they are different from each other. So you can just apply the compound angles. But when it comes to this one, you're going to apply the co-ratios. So guys, in order for you to determine the general solution, you have to find the reference angle. So in order for you to get the reference angle to such equation, you have to now change one between these two using what? Using the co-ratios. Either you change sine to become cos, or you change cos to become sine, right? So I have decided to choose a sine to become cos using what? Using the co-ratios. So this sine 2x can also be transformed by saying cos 90 degrees minus 2x equal to what? Equal to cos x minus 30 degrees. Now both sides we have cos and cos. Then we have positive cos and positive cos, meaning that we have to just pretend as if we have divided by cos both sides. By cos, not by cos x or by cos angle, by cos, just cos. So we have cos divided by cos both sides, cos, then cos both sides, then we are going to left with 90 degrees minus 2x, which is equal to x minus 30 degrees. Then you can just choose any between these two as your reference angle. So I want to decide to choose x minus 30 degrees as my reference angle, right? Then let's now choose the suitable reduction formulas that can allow us to find the solutions for this equation. We have cos and also cos both sides, meaning that we have to focus in the quadrant whereby cos is positive, because we have positive cos and also positive cos. So let's draw our Cartesian plane. So our cos is positive in the fourth quadrant and also in the first quadrant. So let's use the reduction formulas. In the first quadrant we have 360 degrees minus reference angle. Is it plus or minus? It's plus. Reference angle, not minus. But in the fourth quadrant we have 360 degrees minus reference angle. Reason being, positive angles goes anti-clockwise, but negative angles goes clockwise, right? Yes. Then let's now use these two reduction formulas. We have cast, guys, cast. We have cast. All ratios, they are positive in the first quadrant. Sine means angle sine is positive in the second quadrant. Tan means angle tan is, T means angle tan is positive in the third quadrant. Then cos means angle cos is positive in the fourth quadrant. Then let's use these two reduction formulas, because the coefficient here is positive 1. Even here our coefficient is positive 1, meaning that we have to focus in the quadrant whereby our cos is positive. So cos is positive in the first quadrant and also in the fourth quadrant. Then let's start using the reduction formula that is found in the first quadrant. So we have 90 degrees minus 2x equal to what? Equal to the reduction formula, which is 360 degrees plus reference angle. Okay, 360 degrees. Why 360 degrees? Because the period of cos is equal to what? Is equal to 360 degrees. K, 360 degrees, K is an element of Z. K, 360 degrees, K is an element of Z. Then now let's find our first solution. We have 90 degrees minus 2x, which is equal to 360 degrees plus reference angle. Our reference angle is x minus 30 degrees. K, 360 degrees, K is an element of Z. Then let's simplify our equation. We have minus 2x minus x, I've transposed this x, equal to 360 degrees. 360 degrees plus 360 degrees minus 30 degrees is equal to 330 degrees minus 90 degrees. K, 360 degrees. K is an element of Z. We have minus 2x minus x, which is equal to minus 3x, equal to 330 degrees minus 90 degrees is equal to 240 degrees, is equal to 240 degrees. K, 360 degrees. K is an element of Z. Then let's divide both sides by what? By negative 3. Negative 3 divided by negative 3 divided by negative 3. Therefore, our x is equal to is equal to 240 degrees divided by negative 3 equal to negative 80 degrees. Then K, we have 360 degrees divided by negative 3 is equal to negative 120, meaning that we have negative K 120 degrees. K is an element of Z. Or our x, now we are about to find our second solution using what? Using the reduction formula that is found in the fourth quadrant. Then let's say 90 degrees equal to something. Now 90 degrees minus 2x equal to what? Equal to the reduction formula that is found in the fourth quadrant. Then 360 degrees minus a reference angle. K, 360 degrees. K is an element of Z. Why 360? Why K 360 degrees? Because the period of cos is equal to 360 degrees. But if it was tan, we were going to say a k 180 degrees, because the period of tan is equal to 180 degrees. Then minus 2x equal to, or let me just substitute our reference. Let's firstly, okay, we have 90 degrees minus 2x equal to 360 degrees, then minus open brackets. Let's plug our reference angle. Our reference angle is x minus what? Minus 30 degrees. K 360 degrees. K is an element of z. 90 degrees minus 2x equal to 360 degrees minus x plus 30 degrees. K 360 degrees. K is an element of z. Then our x, we have minus 2x plus x, I've transposed this x, equal to 360 degrees plus 30 degrees is equal to 390 degrees minus 90 degrees. K 360 degrees. K is an element of z. Then our minus 2x plus x is equal to minus x equal to 390 degrees minus 90 degrees is equal to 300 degrees. K 360 degrees. K is an element of z. Then let's divide our whole equation by -1, divided by -1, divided by -1, divided by -1. Then our x is equal to minus 300 degrees minus k 360 degrees. K is an element of z. Then this is our second equation. Then after finding these two solutions using what? Using our first quadrant, our reduction formula that is found in the first quadrant, and also the reduction formula that is found in the fourth quadrant, you can just say, use this equation. We can just conclude, this is our conclusion, right? Then use this point, find the general, so the solution of this equation, of this part. Just say minus, let me use a different color. You can just now use this portion by saying minus 2x minus x equal to minus 30 degrees minus 90 degrees. K 360 degrees. K is an element of z. Then simplify your equation. We have our minus, we have minus 3x equal to minus 30 degrees minus 90 degrees is equal to minus 120 degrees, because negative 30 degrees minus 90 degrees is equal to negative 120 degrees. K 360 degrees. K is an element of z. Then divide the whole equation by -3, divided by -3, divided by -3, divided by -3. Therefore, our x is equal to, negative 120 degrees divided by -3 is equal to 40 degrees. 360 degrees divided by -3 is equal to positive 120. Therefore, we have 120 degrees. K is an element of z. Yes. Now let's go for number 2. Let's now go for number 2. Let's find this general solution for number 2. We have our equation, which is given in the form of, this is number 2, which is given in the form of cos x plus 30 degrees equal to half sine x. Then let's find the general solution of this expression. So guys, now let's find the general solution of this expression. Let's replace this by its compound angle. This can be replaced by cos x multiplied by cos 30 degrees minus sine x multiplied by sine 30 degrees equal to half sine x. Then punch cos 30 degrees on your calculator. We have cos x, then multiply by cos 30 degrees. Cos 30 degrees is equal to root 3 over 2 cos x. Then punch sine 30 degrees. Sine 30 degrees is equal to half. So we have negative half sine x, which is equal to half sine x. Then let's transpose this half this side. So we have root 3 over 2 cos x, which is equal to half sine x plus half sine x. So half plus half is equal to 1, meaning that we have sine x, which is equal to root 3 over 2 cos x. Then let's write this equation here. We have now our equation, which is given in the form of root 3 divided by 2 cos x, which is equal to sine x. Then let's divide both sides by what? Let's divide both sides by cos x, so that we can be able to transform our equation into tan, because sine over cos is equal to tan. So this and this will cancel. We are going to be left with root 3 over 2, which is equal to sine over cos is equal to tan x. Sine over cos is equal to tan x. Then we can just say tan x is equal to root 3 over 2. Then let's now, as you can see guys, we have our positive root 3 over tan, mean that we just need to focus in the quadrant whereby our tan is positive. So tan is positive in the first quadrant and third quadrant cast. Right, so we are going to use the reduction formula that is found in the first quadrant, which is 360 degrees plus reference angle. Then in the third quadrant we have 180 degrees plus reference angle, because positive angles goes anti-clockwise but negative angles goes clockwise. Then let's find our reference angle. These are the reduction formulas, right? Then let's find our reference angle. X is equal to arctan root 3 over 2. X is equal to then arctan. We have 40,89 degrees. So that is our reference angle. Then now let's determine what? Let's determine the general solution for, let's find the values of our general solution for what? For x equal to 40 degrees, 40,89 degrees. So x, which is equal to, then let's use the reduction formula that is found in the first quadrant. We have x, which is equal to 360 degrees plus a reference angle k 180 degrees, because it's tan. Whenever you deal with tan, you just need to say k 180 degrees instead of 360 degrees. 360 degrees is meant for cos and sine. So k 180 degrees, k is an element of z. Then x is equal to 360 degrees plus reference angle. Our reference angle is 40,89 degrees. K 180 degrees. K 180 degrees. K is an element of z. Then our x is equal to 360 degrees plus 40,89. Our x is equal to 400,89 degrees. K 180 degrees. K is an element of z. Or our x, then let's go for the reduction formula that is found in the third quadrant. Then we have x, which is equal to which is equal to 180 degrees plus a reference angle k, 180 degrees, k is an element of z, then our x is equal to 180 degrees plus reference angle, which is 40,89 degrees, k, 180 degrees, 180 degrees, k is an element of z, then our x is equal to this 180 degrees plus 40,89. Our x is equal to 220 degrees. Our x is equal to 220,89 degrees. K, 180 degrees. K is an element of z. Then now you can conclude by going to our reference angle. Then you can just say x is equal to 140, not 140 degrees. X is equal to 40,89 degrees. K, 180 degrees, k is an element of z, right? So this is your final solution, guys. So those are the solution for what? For this equation, So thanks for watching, guys. So you can just click on the subscription button so that you can be able to always get notified whenever I upload a video.